Hello everyone. In this particular video, I'm going to tell you about the recursion concepts. That is, we have done already one video basically on recursion concept in which I discussed one question based on the normal recursion concept, and the other question was that I discussed of that was of your Fibonacci series, and I told you one more thing in the end that like uh, though the first term of the Fibonacci series is zero, but you have to mention it in the recursion tree. So this was the thing, this was Fibonacci series, and what it was supposed to be done here, we were using here multiple, we were using here multiple recursion, recursion calls. So now in this particular video, I'm going to tell you about like how we are going to print basically subsequences of a given vector or an array, whatever you take. So how, like suppose if we are given an array which is represented by the letter AR and you have got these elements in an array, this is and this is. So these are your three elements in an array. And now how you have to do here? You have to print subsequences. Now, if you just go on mentioning about combinations, just understand this. If you go on mentioning about combinations, then combinations can come a lot of there. But subsequences are like 1, 2, 1, 1, 2, 1. So just as that case. Now, what you are doing here, if I just basically understand, make you realize this. Now, why I have taken here this example to make you realize about the subsequences printing of a vector. Basically, this concept uses multiple recursion calls, and this will further illustrate your concept of this multiple recursion call, like how it is actually working. So, how we do here is as simple as that. Let me make you realize. Like, suppose we have got three numbers. Okay, suppose we have got the size of this particular given vector is your n, and which is simply here equal to 3. That is quite clear. So what you are doing here in the first case, suppose your subsequence is 1, 2. So you are actually considering here the first element. You are not considering, you are considering here the second element, and you are not considering here the third element. If I take here you in this particular case, 1, 1. So what are you doing here? You are taking into consideration the first element, you are taking into consideration, you are not taking into consideration the second element, and you are taking into consideration the third element. For this particular subsequence, if you are taking into consideration, so you are not taking this into consideration, you are taking this into consideration, and you are taking the last element as well into consideration. Now, if I just tell you that suppose one subsequence is your empty set, that is a set which has got no elements in it. So what are you doing here? You are not considering the first element, you are not considering the second element, and you are not considering the third element as well. So this is the case. Now, if we further take a look into this, what we are doing here? We are actually selecting these elements from a given vector in order to make a particular subsequence. Now, just to make a note of this particular statement that in order to make a particular subsequence, we are actually selecting elements from the given vector. Now, what I mean by selecting here is simply that either we are taking this particular element or we are not taking this particular element. So we have to take into account all the possibilities and how we have to do it. Simple. So it is that case. Like we have to take here, we are taking elements. So taking is represented here by take, and not take is simply represented by across here. So this is basically idea of how we will be printing the subsequence. Now, how we will go about this. So if I just simply tell you how we go about this. So let's see how we will be going about this. So first to because this is for basically your multiple recursion calls. So how you are going to make it? Firstly, we are going to create a recursion tree here. What we are going to do, we are going to create a recursion tree. So Recursion tree will be having like this. This will be a particular function which will be we will be actually recursive function. This will be which will be doing what? This will be actually printing the subsequences. Inside this, we will be having index, and this is a recursion tree. So we just simply need a particular data structure which will be storing the what you call as the data structure. We will be needing a particular data structure which will be storing the subset temporarily. Finally, you have to return all the subsets. So you will be using a vector of vectors, which will be simply be having all the subsequences. So for temporary, you have to store the particular data structure before you simply push it finally into the vector which will be returning. So we will be taking here an index which will be index I, and this will be a particular data structure which I have been representing here by the letter D. So now we start. Now, in order to make a particular subsequence, we will obviously be starting from the index 0, and that is simply here your 1, isn't it? So like I will be moving on to the next. So what? Here is 0. Now we have the possibility of that if we take the element or not take the element. So, our initially the pointer is at the index 0. Now just notice when the initially the value of I is 0. So you have the possibility that you can take the element at the 0th index, or you can't take the element at the 0th index. So suppose I take the element at the 0th index. Suppose I take, then the next case will be that I should move on to the next index. So I will be doing I plus 1 here. And my D will now be having something that I have picked. So now if I have picked, D will be having the element 1, because the element that was placed was simply 1 at the 0th index. Suppose I opt not to pick it or not to select it, then still I will be moving on to the next index. And but my data structure in this particular but my data structure here will simply be having no element. Like here, D will be equal to 0. Now, as I told you in your last as well, that last lecture as well of recursion, that is the first part of the recursion series, that that left part of the recursion executes first. So how you are going to do it? Now, I presume it that the left part is executing first. So how it will execute? Now, just look at this. So you have again got the option that you can pick the element placed at the first index, because from 0th index, the pointer will move on to the first index. So you have got the option to actually check that whether this particular element you have to pick it or not. So the first possibility is that you will pick it. So I will move on to the second position, that is the last index. And my data structure will now be having another element. So suppose my data structure now will be having what? My data structure will be having 1 and 2. I have another possibility, which is what? That I move on to the next index, but I don't pick the element. Now, in this case, what? Your D will just be having this particular element because you picked the first element that was at the 0th index, but you opt not to pick the element at the next index. So again, left part of the recursion will be executing first. So it has got what option? Again, it has got two options. So suppose it has got two options. So like it will it can't move on to the next. So if it goes on to the next, then you were already placed at the last index. So now you have actually the value of index is actually become equal to the size of the vector, and your data structure will be having something. Now, since in the first case you opted to pick, so your data structure will be having the subsequence that is 1, 2, and 1, or you opted not to pick it. So this you will still be moving to the next index that is actually equal to the size of the vector because you were already placed at the last. But here your D will not be equal to 1 to 1. It will be equal to 1 and 2 because you opted not to pick the last element. Now, now here comes the chance that you were already placed at the last index. So now you have no more elements to make a subsequence. So what will be the base case here? So base case will be simply there when the index becomes equal to the size of the vector. Then the sequence that you have got till now, the sequence that has been stored in this particular data structure, you will simply be pushing it into the a nested vector of integer data type which will be holding all the subsequences. So, and you will simply be using the word here return. Return does what, as I've told you in your previous video as well, that it actually backtracks. So now you will be backtracking it. So while you are backtracking it, you have to simply keep this idea that you have to pop this element out as well. That is, you have to remove it because you don't want that when you are coming again to the next case, you don't want that when you are coming to this particular place. So one is already added. So you will pop out and this will become one and two. So now this recursion is over. So pointer will move to this. So this have already reached to this is also reaching to the size that is equal to n. So this will also return. So now this happens. Now this happens in what case? This is simply equal to like this is simply equal to yours. What it is? It is simply equal to you will again pop this element. So this will become one. As simple as that. So again this will be executing. So this is a particular case. I hope it is executing. So basically what we have to do, we have to firstly check till this. And if you just ask me the number of recursion calls, that is your stack space, if you just see it is the number of recursion calls. If you just take one left side, if you just take here the one left side of the recursion tree, you will find here the number of recursion calls that are being made are equal to the number of elements inside a vector. So your auxiliary space is simply equal to big O of n. And if you just find your time complexity, so your time complexity is simply is equal to, because you are getting for every index you have got two choices. Just remember this. For every index, remember this. For if my index pointer is placed here, so you have got two choices. You have got here two choices. You have got here two choices like this. So your time complexity will be 2 to the power n. And since you are pushing it into a vector, so that takes the time complexity big O of n. So this will be your time complexity, and your space complexity would be the number of subsequences. Like suppose if I assume that the number of subsequences that are being generated are x, and each because subsequences is space complexity is clearly defined by the number of elements that a variable will be holding. So the number of subsequences that will be generated for a given vector of size n are equal to x, and its average length is k. So this is your space complexity. I hope it's clear. So if I just revise you before moving on to the code, what we are doing here, we are simply we are simply doing what? We are simply actually we are initially at the zeroth index, so we have got the two possibility, either to pick it or to not pick it. If we pick it, then we move on to the next index. Even if we don't pick it, then we will still be moving on to the next index, and then the so on it continues. Finally, if the value of index becomes equal to the size of the vector, then we have to push back that particular data structure into the final vector, and then we have to backtrack. This is a particular code, and if I go to the code like this, you have to write here. So this is your particular syntax here, that what you have to do. Suppose at particular index, so if this value becomes, I've written here greater than equal to n, you can always take equal to n as well. So I have actually just printed the particular vector. I haven't actually just stored it. You can store it as well. You can print it inside the main method, but I have actually printed it. So that makes the recursive function as non-return type, that is void. So this is the case. So what I'm doing here, I have taken here a temporary data structure, and I have actually just printed it. And this is the particular vector which is holding the all the elements initially that for which you have to generate the subsequence. And this is your size, the size of the element, and this is the particular index. So what I have done here, initially I have pushed back the element, and then I have actually moved the index to +1, and till the time this will run, and this will run till the time it has not condition has become true. And then what will happen, simply you will actually, when it will backtrack, remember this, when the function will backtrack, then you have to remove this particular element, and then you have to again call it. So this condition, you can see, this condition is for picking the particular element, this condition is for not picking the particular element. Remember this, condition for picking the particular element, condition for not picking, remember. So then I created here a main method, and you can find a vector. So this vector is simply particularly to store the data structure temporarily. This is not. Then I have passed the size of the vector, that is actually 2 here. And finally, I've called this particular function. So I haven't used here a class. So I haven't assessed the function using objects and all. So if I just take this example of what I explained you, so if I just run this code, you will find the answer. So this is the code, and hopefully you will be getting the answer. So hopefully we will be getting here, and yeah, we have got here the answer. This is your subsequences. These are the number of subsequences that you have to generate. So for a given vector of elements which has 1, 2, and 1, remember this, for a given vector which has got elements as 1, 2, and 1, you have got here the subsequences which are 1, 2, 1, 1, 2, 1, 1, and all. So this is the code. Now we move on to another thing, like we have to simply print one element. Like if I say that suppose you have to print the subsequences of a sum k. So I will also be telling you how you will be printing for the sum k, and I will also be telling you a few more concepts related to that. So just stay tuned. I hope that it's clear. So moving on, now I will be telling you about like if you have been mentioned in the question. So like if I just clear this. So if I just mention here that your given vector is just the same that you had taken in the previous question, but there is a slight change that in the printing of the subsequences that you have to print the subsequences which have the sum equal to k, like this. And here I have taken k equal to 2. So, which will be the subset that will be contributing to, or subsequences, sorry, the subsequences which you have will be having the sum 2. So, if you want to actually check it, so roughly the idea of the output that you will be getting here, it will be simply 1, your subsequence will be 1 comma 1, the other will be 2, and other than that, you won't find any subsequence which will be having its sum equal to k. So, how you will be doing it? So the idea behind this is very simple. Again, you will be finding here that it is a condition of picking, not picking, then picking. Simple. Or it is a condition of simple, like what? It is a condition like simple, you are not picking, you are picking, and you are not picking, like this. So how you do this? So moving on, we will be having here initially. So our recursive function was taking the parameter like what? It was taking the parameter simply the index and a data structure which will be storing the subsequences temporarily. This was the case. So we will be again be taking that particular data structure, and along with that we will also be storing the sum. We are actually, this is making a recursion tree. Finally the function will be having something different. So we are also making storing the sum of the particular subsequences, like we are also storing the sum of the subsequences, because ultimately we have to mention those subsequences or print those subsequences which will be having a particular sum. So what we are doing it, we have to do like that only. If we pick, then our index will move to the next place, and our data structure which is holding the subset will be having some value, and similarly the sum will also be incremented. So in this particular case your data structure has become equal to 1, and your sum has also become equal to 1, as simple as that. And now you will see, if we don't pick, then we have to move to the next index. So we will be moving to the next index, and then we will be doing your what? Then we will simply be, our data structure won't be having any element as of now, and so will be the variable sum. So now left part of the recursion tree will be executing first. So if we pick this particular element, because this particular index will also have two choices, suppose if we pick it or not. So if we pick this particular element, so we will be moving on to the next index. Our data structure will be having another value, and the sum will also be having another value. So now sum has become, the value has become equal to 3, and your data structure has got the value 1 comma 2. So, and if I don't pick this particular element, so I still have to move on to the next particular index, and data structure will be having only 1, and some will also be having value 1. Now, this particular index will also have two possible values that it should pick the value. So suppose it picks the value. So if it picks the value, then index will obviously move to the next place, and you will be getting here a particular data structure and sum. And suppose if it doesn't pick, so what will be happening? You will still be moving on to the next index. You will be having something in your data structure, and you will be having in something. So suppose if I pick it, then your data structure will become 1, 2, and 1. As simple as that. And your sum will again become equal to 4. And if I don't pick it, then it will remain these two values. So this is the case. Now you have reached your value of index it has become equal to the size of the vector that was discussed just like the previous case. So what you will be doing? So when you will be reaching this particular condition, that when your index has become equal to the size of the vector, then you will be doing what? You will simply be checking that is the sum equal to the required sum. If you have it, then you simply print that particular data structure which is holding the subsequence. You will simply print. You will be checking what? When the index has become equal to the size of the vector, then at that moment you will be checking that has the sum of the subsequence, like is the variable as equivalent to the variable sum. As simple as that. And if it is, then you will display it. If it is not, then you will simply return it. Like it will backtrack because you don't have to mention those sequence. So it will backtrack. And while backtracking, you have to remove those elements. Since you don't want to, then when you have to come back here again, they are already present. So this is the case. So this is the case. And remember this, time complexity, space complexity, and your auxiliary space won't change. They will just remain just like the previous uh, type that we discussed. So we're moving here that to the code. And here is what? Here is one thing that you will be doing here. I will be actually doing here if s equal to sum. So I will be doing here what? I will be putting it here inside this. And along with that, now why I've done here, just look at it. So I will simply be doing here, and now it is not actually defining it. So I will be doing here what? I will simply be mentioning here int sum. Now this sum is equal to 2 because we have to mention those subsequences which have their sum equivalent to 2. As simple as that. So I will be using here another particular data structure that is your 0. That is initially the value of the variable s in which you are actually storing the sum of the subsequence, and you are comparing it with the variable sum. So this is the case. Now this is will be giving you an error. So I will be doing here what? I will simply be using here comma ints comma int sum. So I hope this is like ints comma int sum. So this has already got s. So you will be doing here what? You will simply be using here as s1. I hope that is clear. So here we will be using here as s1. And so basically you must be getting an idea, or just look at it. So here we have got s, and here we have got s1, and along with that we have got the variable sum. So again we will be making a change s1 comma sum. So when we are pushing the element, so we are doing here what? We have to increase s1 plus equal to what is your you have taken the vector. So s1 is plus is equal to vi, just like that. And when you are popping back, so before popping, you have to like simply before popping, you have to actually reduce the value of sum. Like whatever you added to the variable s1, you have to minus it. As simple as that. So this is the case. And if we are getting an error here, so how we actually why we are getting an error here? So We are not getting an error, right? So like therefore we are getting an error. So hopefully now it will be solving it. So you have got it, and you can simply let's see what it. So now before I run the code, you have to get an idea what I'm doing here. So let us see what I'm doing here. So I've created here a function which will actually be displaying the subsequences which of a given vector, which will be having its simply, which will be having its like what? Let me do it. Hopefully this is okay. Yeah, yes, all good. So what will be it be doing here? Simply, I've created here a function which will actually be printing those subsequences of a given vector which have the sum equivalent to k or some any kind of a number. So what I've done here, like this is your base condition. You can write here greater than or equal to. It doesn't make any sense. So it should be like when your index has become equal to the size of the vector, then you are checking that is the value of sum, is the value of sum which has S1 here is basically the sum of the particular subsequence is equal to the sum. So if it is, then you will print that particular subsequence and like this. So you will simply be doing here it like this and this like this. You are mentioning here, you are simply displaying this particular subsequence. And if you are just talking about, so this was just the same, you are pushing back the element inside the vector which is holding the data structure, that is your subsequence. You are also adding that particular number in the sum because you have to like to simply compare it, that has the sum which is comprising of the elements of the subsequences is equal to the given sum. You are again recursively incrementing, moving on to the next index, and this will reach the particular element as soon as this condition is satisfied. So if it doesn't print, it will return, or even if it prints, it will return. So it will backtrack. So while backtracking, before popping out this element, you have to also decrease or you have to reduce the sum by that particular number. And then you have to pop that element out, and then you have to simply again, this condition is for picking the element, this condition is for non-picking the element, that is true. So if we go on to run this code, you will find the answer. So like what is the case here? You have got the answer. 1, 1, and 2. So that was what you needed here. As simple as that. What you got here? You got here 1, 1, and 2. And these are the only two subsequences which have their sum equal to k. So this was all about this. Now we will be moving on to the concept of printing only one subsequence. Like there are multiple subsequences are coming, but we have to print only and only one subsequence. So ideally, it's what? Ideally, it's what? That I will taking here a Boolean variable. Like if I do, like we normally study the concept of flag. So a flag does what? Suppose if we have got that result, then it acts like a pointer and that shows that you have got once a result. So it is normally used in frequencies and every kind of things like that. So that is a particular thing. Like we will be doing here what? We will simply be doing here. We will be taking a flag and we will be taking here simply what? Just see, we will simply be taking here a boolean variable flag, and if it prints for once, like if it goes inside this, then we after printing once, I will make boolean flag equal to 0, and I will just simply write here if flag not equal to 0, then simply return, as simple as that. Then that will also give, suppose I do this for you. So what is it like, suppose I write here bool flag equal to 1, as simple as that. And after printing this particular statement, I make the flag equal to 0. And then I write here, if flag, if flag becomes equal to 0, then you can simply return it. So now you see what will be the difference in the code. So I'm running it and you will find. So it not give any output. So like what is the case here? We will be checking here. So, so the problem for which why we were not able to print it, like I have made here flag equal to 0, but for the next time you have to check here that suppose I write here, I have to mention the condition flag equal to 1. Like if the flag is value is equal to 1, because now flag has become equal to 0. So I have to do here what? Next time this particular condition and you won't find this particular thing. If I do it like this, let's see what it comes, the output comes. We will be seeing here. So if I just do it, we have got here 1, 1 and 2, as simple as. So why we are getting that particular condition? Let's see if we are still not getting it, as simple as that. So the reason why we are not getting here is that there is one silly thing that we have done here. That is when we are recursively calling it, then this particular function, the count, the control of the function comes here. So again, it is making flag equal to 1, as simple as that. So we will take this element. I will be taking this particular element that is, and I have to mention it like this. Like this should be written here equal to 1. And now you will be getting the answer, as simple as that. You will be getting the answer like now this control, once it is changed to 0, it won't affect. So let's see. This time we should get only 1, 1. So let's see. We have only got the subsequence that is 1, 1. So this is one method of printing the number of subsequences, or this is one method of printing only one subsequence. Remember this. If you want to print like this, so this is one thing. But if you, since we are studying here recursion, so if you want to take it into the recursive concept, like you have been asked to print only one subsequence which has got the sum equal to k. So how will you go about? So I will simply erase this, and this is of no need here, and this flag should also again get removed. So this is of no need. As simple as that. So how we'll go about thing, you will just get to know. So, so now in order to print only one answer through recursion, you have got this particular thing, which is simply what? You have to remember this particular thing. This is basically method. This is what? This is basically your method of printing one particular answer. This is the method of printing one particular answer here. So how you have to do here? You have got here your particular function which you are creating, and you have to just remember this. Suppose and then you have got your base case. You've got here, you have got here your base case. So if certain condition will be there, just understand this. If there will be a certain condition, so you will return true. Just understand this particular condition is very important. You will return true. And if that particular condition inside the base case is not being satisfied, then you will return what? You will simply return false. Now, still this particular f is continuing. I haven't put the curly braces, so I'm moving on to the next frame, and I will be writing here. Like then you use here two recursion calls, because there is multiple recursion calls, because you're making one recursion call for picking the element and the other you are making for not picking the element. That is for the backtracking time. So what it will happen like this, understand? So if I haven't put the curly braces yet, so if your recursive call f returns equal to true, that is if the condition is being satisfied, like if you are picking the element, then you will doing here what? You will simply return, you will simply return here true. Got it? And if you like or you are not able to if this particular condition is not like this will apply for both the functions, you will get to know it. And if this is not getting fulfilled, so you have to write here simply return false, as simple as that. You will be writing here return false, as simple as this is the case. Again, I'm going back to explain you. So inside your function, this is your function. Basically, this is your function. And inside a function, the structure of recursion has its base case. So this is your base case. And this particular base case will be having some condition. This is generally your if. So if that condition is being fulfilled, then you will return true. Else you will return false. Then what? Then I will be placing a curly braces. Your function is O. And then you have got two recursive calls. Like you have got two recursive calls to make here inside the subsequences tag kind. And that is one for picking the element. The other is for not picking the element. So if you want to pick the element, then you have one recursion call. So suppose that is equal to true. So you have to return true. And for not picking recursive call, you will also be calling for this. This is the particular syntax. Wherever you are calling the function, you have to do it, mention it like this. Or if both are not returning the condition, if both are not returning the result, then you will return false. As simple as that. So now you are see we are returning here true and false kind of thing. So it will just simply remain what? It will simply remain like the return type will be boolean. So moving on. So how we'll be doing this? So there will be some changes like what? So the changes will be as simple as that. This will be Boolean, and I will be returning here, like I will be doing here. Inside the base case, I will be returning true, as simple as that. I will be returning here true. Now there won't be return here. It will be simply like this because anyhow this recursion call is being coming here. Like even if the sum is not equivalent to the given sum that is being required, so still this will come inside this. So suppose this is not being executed. This particular part, your S1 equal to sum is not being executed. So you will be returning here else, else return false. As simple as this is basically from where I just mentioned you here. Inside a base case, inside a base case, if this particular condition is fulfilled, you will return true, else you will return false. As simple as that. So I move on here. Like this particular condition, if fulfilled, then you will return true, else you will return false. Now, reason I have put here else return inside this, the reason being is that anyhow, whether you are picking the element, whether you are not picking the element, whether the sum is being equivalent to the given sum, you are still coming inside this particular case. So now you're doing how? As simple as that. So you are simply putting here if this particular function, I will be placing another bracket here, is equal to true. This is the what case. Then you will be returning here return. You don't need to change anything barring that. Again, you will be doing here what? You will place here. Just understand this particular thing. So like return. No, this should be equal to true. Then you will be returning here. Return true. Else, suppose both are not fulfilling conditions. Both are not fulfilling conditions. Then you will do what? You will simply do, you will simply return false. As simple as that. Now you will be noticing from where did this come. So firstly, I will format document and then I will do here. I'm simply doing it like this. Just see, as simple as that. So this is the case. Now, how I did this, you just have to realize it. So I just mentioned it here inside that if the function that is your recursive call is returning true, that is returning the positive result, that is equal to true, then you are returning true. And if it is not returning the result, like it is not picking or something kind of that, it is returning false. So you have to write it like this. And both the recursive calls will be mentioned in the form of if equal to 2. Remember this. Both the recursive calls will come and get mentioned in f equal to 2. Remember this thing. Both recursive calls will come and get mentioned in f equal to true form. True form, remember, f equal to true. And if both the condition, like for pick and non-pick, both are returning not true, both are not returning true, then you will return false. As simple as that. So I am thinking that like it's all good. So you are just simply saying here, if I just mention along with the code, so inside this particular case, we have got a base case. If base case is getting true, then it is getting executed, then I'm returning true, else returning false. If the recursive call is returning true, then I'm returning true. And if the recursive call is not returning, like if the recursive call is returning true, again I'm returning true. This is both for picking and non-picking. And if both are not returning the true value, if both are not returning true, then I'm returning false. As simple as that. So I don't think any changes there. The code remains the same. So we will run this code and we will find what will be the output. Output is 1 and 1. You just realize what is the fund. The basically the technique of this printing is that you got the output. That is the very first case. You got two factor that was 1 and 1 and 2 that were coming, that was sum was equivalent to 2. And here you have got 1 and 1. So this was what we expected. And so basically you have to remember this particular technique, what I've told you here. You have to remember this particular technique. So moving on, the last is that suppose initially we were having something called as the number of subsequences which were having the sum equivalent to k. So we got two subsequences, like for a sum equivalent to 2. So we have to return this time the number of subsequences that we have to print. So we will see that, and this is the last type concept that we will be studying here. So we move on. So moving on, we will be having the last thing, that is counting. All right, we should use this. So the last thing is counting the number of subsequences. That is counting the number of subsequences. So now we will be counting here the number of subsequences which are possible from a elements of a given vector whose sum is equivalent to k. So what we are doing here, we have got a vector which is just the same that we have been using up till now. So this vector is your 1, 2, and 1, and your sum value has got its sum equal to 2. So now you have already been knowing that the required subsequences will be 1, comma 1, and the other subsequence will be your 2. As simple as that. Is that clear? So this will be your subsequences. So now what will happen? As simple as that. Just understand this. What will happen? Here you have to take in mind that here what we are doing here, the technique of printing. So now, now there will be a method. There is a method because we can do it like count plus plus and all that, you know, basically. But if we are studying here recursion, then what is the recursive way to do it? So we will be understanding here the method. So this is your function which you, that is your recursive function. This is a function in which you will be doing. So the recursive function structure is something kind of a base case. Is that so? You have got a base case, and inside a base case, you return true. Remember this. You return not true this time, you return 1. If condition, I'm writing it here. If condition, if your condition satisfies, remember this. If your condition satisfies, like you know, basically the structure of a recursive function, there is a function header, and inside a function header, there comes a base case. So if the base inside the base case, if the base case is there, and if the condition is satisfied, then you return 1. Else you return, or you write basically return 0. As simple as that. You can use here else as well. Else you return 0. Now this is very corresponding. condition not satisfies, as simple as. Then we will be moving to the next frame, and you will be seeing here is that we will be taking here L, that is an variable of integer data type. We will be doing here what? We will be simply taking here and value integer, because eventually we have to return here the number of subsequences. So that is obviously an integer value. So the return type of the given function this time will be integer. So we will be taking here, and this will be taking here the function call, as simple as that. You will be noticing here. This will be taking here the function call, as simple as that. This will be taking here the function call, as simple as that. And you will be again be considering here the variable int r, which will be taking the function call. So now you will be finding what is the difference. So this will be for taking the element, and this will be for non-taking the elements. We are making two recursive calls, as you know that this is a concept of multiple recursion calls. So we'll take it. And finally, if we have to return the subsequences, so basically it is return your L plus R. So now if you want to get the intuition of this particular thing, so I will take you to the initial type of concept where I have done here. So if you just look at here, so if you just find, suppose if I go to sum, I will take you to the sum structure. Suppose this was the recursion tree. And if I tell you the sum was equivalent to sum is equal to 2, and you have to find the number of subsequences. So there is a possibility that a subsequence can be formed by actually picking all the elements, like you pick and pick, and some suddenly you reach the particular last index, and then you find it that this particular subsequence is equal to the given sum. And there is a possibility by not picking it as well, you find it. Supposedly I not pick. Initially I not pick, and then I pick, and then I don't pick. So there is a possibility. So the intuition behind this particular the technique is as simple as that we have to take into account the number of subsequences that are can be found by this, that is number of times this is, and the number of subsequences that can be found by this, and finally we will be returning. So like I take you inside a recursive function, inside a recursive function inside a recursive function, there is a structure, the function header, and then comes the base case. So inside a base case, if the condition is satisfied, then you will return 1. And if it is not being satisfied, then you will return here 0. As simple as that. And then you will do here what? The first recursive call that you are making for picking the element, you will store it in the variable L of integer data type. And the recursive call that you are being making for not picking the element, you will store it in the recursive call in the variable R of integer data type. And finally, you will return L plus R. As simple as that. So we'll straight on, we'll move to code. And this time with only little bit of change we will be finding here. I will be returning here. With this time, we don't have to print the subsequence. So I will simply remove this particular thing because we don't have to print. So there is no concept of endl also, because we have to simply return the number of subsequences. So I will be using here as 1. Suppose it is not being satisfied. So I will be using here as 0. And now I will doing here what? Like I have to do this because the condition was, next condition was what? Next condition is to store this particular, let me do this. Next condition is to store this particular recursive call inside this. And we won't return anything this time, as simple as that. And like you can delete the extra variables that are being used here, like you can delete it, as simple as that. So I will do this int r, and this should be removed, as simple as that. And we are doing here what? Like this. Finally, we have to do here what? Return L plus R. As simple as I hope that is clear. So we haven't got any syntax error. And if I just take you, so what was the case? Basically, what we did, if I just take you back, we have got the recursive function inside a base case if the condition is satisfied. Again, I'm telling you why I put return zero here and not here. The reason being is that anyhow, if we are reaching the last particular index, this particular time, we are coming inside. So satisfied and not satisfied condition comes from this. This is basically your constraint that S1 is equal to sum. Suppose this condition is being satisfied, you will return 1, else you will return 0. Then you will come outside this particular loop. Then what we had to do? We had to store the particular recursive call being made for picking the element in the variable L and not being made for variable R. And finally, we had to return L plus R. So we have to look that we have did it. We have stored the condition for picking the element inside the variable L, not picking the element inside the variable R. And finally, we are returning L plus R. As simple as that. So now we will be running the code and our sum is clear that sum is 2. So let's see what is the output we are getting. Let's see. We are not getting any output. The reason is that as simple as that. We never stored it inside a variable. So what we have to do it here? We can simply do it. I will be mentioning here number of subsequences because this is remember this. The function was not void, it was of integer data type. So it will be returning a value that is of integer data type. So we have to do number of subsequences, or to make it more clear, it will be the number of subsequences possible. This is a case. Then it will be like this. I hope it is clear this time. And it has got no syntax error. So I will run this code once again and let's see what happens. I hope this time the problem you are getting here. So you got the answer here. The number of subsequences possible is 2. That is because the two subsequences that will be possible here is 1 comma 1 and 2. So you just got to know this particular thing. So just like that, these two are techniques. If you are doing recursion and if you want to follow the method of recursion only to get the one subsequence and to count the number of subsequences, that this is the method. And if you want to use it, then you have to remember this particular technique. So this was all about recursion concepts like multiple recursion calls and your single call, like if you are printing factorial or any kind of a basic recursion. So both have been discussed, and more questions like rat in a maze and your n queen problems, which actually involve the very similar concepts, multiple recursion calls you have to make. So basic idea of you have got, and those will be the problems that will also be done. So you can just understand this and you can go through it once again. So hopefully you have understood it, all the concepts, and this was all about this particular video in which you must have learned about subsequence printing. You must have learned about printing subsequences equivalent to k, and then you must have learned about the printing subsequences, one subsequence which has got sum equal to k, and then you have learned about the number of subsequences that are possible which have the sum equal to k. As simple as that. So you got to know about these things. So hopefully you must have understood. So thanks for watching. Do like, share, and subscribe. Thanks for watching. Thanks everyone for watching. Stay tuned for more content. Thank you. Do like, share, and subscribe as well.